Okay, so example 5, which is on principle of homogeneity. Okay, so a convex lens has a focal length f and its surfaces have radii of curvature r1 and r2. The refractive index of the material of the lens is n. All these quantities are related through this equation, show that it is dimensionally correct. Okay, so we know that homogeneity ni kita perlu equate left hand side equal to right hand side in order for it to be dimensionally correct. Okay, so let's look at the left hand side. Left hand side equation is 1 over f. F here is a focal length. So from here we know that the dimension is L negative 1. So why is it L negative 1 is because this is 1 over f. If they are f saja, we know that their punya dimension is L. But since they are 1 over f, we are using L negative 1. Okay? Alright. Next is the right hand side. So right hand side is n minus 1, 1 over r1 plus 1 over r2. But we know that n is dimensionless. So we can just remove that n and use 1 over r1 plus 1 over r2. Okay? So from here we can see that we have L negative 1 plus L negative 1 juga. Okay? So why do I put L here? Because radii of curvature is a type of length juga. It's a type of measurement for length juga. Okay? So that's why we put L. Okay? So let's equate this. 1 over f equal to 1 over, oops, I forgot the n minus 1, 1 over r1 plus 1 over r2. This one, it has its own dimensions. So 1 over f, we dapat just now apa? L negative 1. And then n minus 1 is dimensionless sudah dorang. So we get L minus 1 plus lagi dengan L minus 1. Okay? So we know that this one is equal to L negative 1. Okay? So based on this, we can then see that the equation is dimensionally correct. Okay? So kenapa Miss tidak dapat 2L negative 1 pula? No, it's not like that. It is based on these rules. Okay, so it is based on this rule here. So when we have L negative 1 plus L negative 1 plus lagi dengan L negative 1 plus L negative 1 blah 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 tu, it will still be equal. Okay, jangan kamu pergi tiba-tiba tambah 2L negative 1. Tiba-tiba kamu jawab, it's not dimensionally correct pun. No, it's not like that. If there's a plus minus between A plus B, the dimension will still be equal to each other. Okay? Okay, next is on example 6 lah. Right, so determine whether the following equation is dimensionally correct or not. This one, so F is the frequency of the simple pendulum, L here is the length of the simple pendulum, whereas G here is the gravitational acceleration. Right, so let's see for left hand side. So left hand side is equal to F, in which dia punya dimension is formula there is 1 over time. Don't write like that lah. So 1 over time is the formula for frequency ataupun 1 over period actually. Alright, so 1 over t is equal to t negative 1. Dimension dia t negative 1. Boleh faham kan kenapa? Sebab sekarang ni dia 1 over t, we are doing this t negative 1. And then t punya dimension, which is time, is capital T. Okay? Alright, next is right hand side. So the right hand side, from here we know that 1 over 2 pi is dimensionless. dimensionless. And then, so the right hand side, we only have G over L. G lampau besar, G over L, square root of G over L. We convert this in terms of square gitu-gitu semua tuh in indices, I think indices. So 1 over 2, and then we have L, which is negative 1 over 2. Okay, so why is it negative? Is because dia ada per di bawah, per length. Okay, right, so we know that gravitational acceleration, it is the same with acceleration that we did in the previous examples. So acceleration, we know that it is equal to displacement times dengan time square. Okay, and then we have length here, which is length lah, length je lah, length negative 1 over 2. Okay, so this one is L, this one is T square, this one is L negative 1 over 2. Okay, oh, I forgot, sorry, but this one, we have to times it with 1 over 2. Why? Because 1 over 2 here is symbolizing the bracket. It is the square root. Okay, it is the square root. 1 over 2 is the square root lah. Okay, so let me do this again. So displacement is L. Why is it black? So it is L, displacement is L times dengan 1 over 2. So we have 1 over 2 here, and then we have the time, which is T. 2 times dengan 1 over 2 means we have removing the 2, so just ada T saja. Okay, so then you will get L. Mari, I'll do this supaya you can understand what I'm trying to do. L, then we have square root of L lagi. Then you have T di sini. T, aduh, silap. Yeah. T negative 2, time. Why negative 2? Sebab tadi pun sudah Miss letak dia per, sepatutnya dia per meter per second square kan, so sepatutnya dia ada negative 1 di sini. Okay, so we have T negative 1 here. Alright, so if we simplify this, we are removing the square root L, so we can get the dimension is then T negative 1 saja. So let's see, right hand side is T negative 1, left hand side is T negative 1. Since they are equal, we can then say the equation is dimensionally correct lah. Okay, alright, last example 7. So for example 7, we have to show that this equation as equal to blah blah, this one is dimensionally correct. Okay, so okay, left hand side is S is a length, so we can write length and then L. Okay, so it is L. And then the right hand side, 1 over 2 here is dimensionless. This one over 2 here is dimensionless, so we can continue. U is a speed. Let me write first. Speed at velocity lah. We write known as just write U lah. So T is time plus half acceleration T square. So we know that speed or velocity, the velocity is equal to, dia punya dimension is S per st negative 1 st negative 1 times lagi dengan T here plus half acceleration is st negative 2, lepas tu we have T square here. Okay, Yang ini Miss dapat dari kita punya previous examples as the same thing as acceleration. Yang ini pun dapat dari previous examples. Okay? So, right. So, now we know that S is equal to length, which is L. T is equal to time, which is T negative 1. Then we have time again, T negative 1, T negative 1. Kenapa T negative 1? T je lah. See, T je tulis. So there's no negative 1 here, okay? So plus dengan half, S is length, T is time, T square lagi pun time. Okay, so which one yang can be eliminated is this one. Let me use another color. This one, as well as this one, can be eliminated from the equation. So you will then get L plus half L. Again, remember the rules. So we can say that left hand side is equal to the right hand side. So they are dimensionally correct. Okay. Alright. So if you do not understand how I do this, feel free to not WhatsApp me, Telegram, message me on Telegram so that I can explain more in detail which part that you do not understand lah. Okay. So that is all of our examples for subtopic 1.1.